This episode is about salts and the neutralization reaction. A salt is an ionic compound that contains a metal or a polyatomic ion as the positive ion and a nonmetal or a polyatomic ion as the negative ion. Basically, almost all ionic compounds are salts except hydroxides and oxides. The negative ion cannot be hydroxide or oxide. Let's take a look at some examples of salts and examples of compounds that cannot be called salts. So all of these are salts. We have positive ion, be it a metal or a polyatomic ion. The last one is a polyatomic ion, positive ion. We have a nonmetal as the negative, nonmetal, and a polyatomic ion. These are all examples of salts. What are not salts? Potassium hydroxide, if the negative ion is a hydroxide, is not a salt. Calcium oxide, if the negative ion is an oxide, that's not a salt. We have learned a lot about salts. We have learned how to write the Lewis structures of ionic compounds. Most of them are salts. We have learned, given a positive ion and a negative ion, how to figure out the formula of the compound they can form. Basically, you take the number on the positive charge, put it as the subscript of the negative ion, and the number on the negative ion, put it for the positive ion as a subscript, and make sure they are in their simplest ratio. We have learned predicting the solubility of ionic compounds. We have a table, a guideline table for the solubility of ionic compounds. Well, we are going to learn a little more here. All common soluble salts are completely dissociated into ions. Okay, we learned that early in this chapter. We specified when we were talking about the dissociation, we specified that not only Arrhenius base dissolved in water is dissociation, also some other compounds like salts. When they dissolve in water, the process is also dissociation. Dissociation is a process where ions are generated from an ionic compound in water. All right, so all ionic compounds, if they're dissolved in water, if they're soluble in water, they will dissociate into ions. A salt is one of the products from a neutralization reaction, a reaction between an acid and a hydroxide base. Oh, a neutralization reaction is a reaction between an acid and a hydroxide base. We don't know what the reaction is here right now. We don't have any example yet, but we know what a hydroxide base is. We know what an acid is. So when an acid is a proton donor, if you react something that can donate a proton, react it with a hydroxide base, for example, potassium hydroxide, that's hydroxide base. If you react the two, they will produce some products, and one of the products will be a salt. Well, let's take a closer look at that. Let's look at the neutralization reaction. It is a reaction between an acid and a hydroxide base. Oh, we noticed it was on the last slide, in which a salt and water are produced. Oh, a neutralization reaction will produce two products. One of them is water, the other of them is a salt. Let's look at a couple examples here. An acid, hydrochloric acid, a hydroxide base, sodium hydroxide. The product, water, sodium chloride, a salt. The second one, an acid, sulfuric acid, a hydroxide base, potassium hydroxide, the product, water, and a salt, potassium sulfate. Looks like all of these are double replacement reaction or exchange reaction. So look at the first one, in the reactant, sodium is combined with OH. Eventually, after reaction, sodium combined with chloride and hydrogen combined with OH. Double replacement or exchange. Do you guys notice that? Same thing here. Before potassium is combined with OH, hydrogen is connected to sulfate. Afterwards, hydrogen combined with OH, potassium combined with sulfate, potassium sulfate, water, HOH, water. I see. A neutralization reaction is an exchange or double replacement reaction. Yeah, okay, we know that. It makes sense. It indeed is. The salt formed contains the negative ion from the acid and the positive ion from the base. Oh, okay, let's focus on the salt. Again, let's look at the first one. We're going to look at both. So let's look at the first one now. In the salt product, the positive ion actually is from the base, sodium hydroxide. Makes sense. The negative ion comes from the acid. After donating the proton, the leftover is a negative ion which is in the salt. So the salt formed contains the negative ion from the acid and the positive ion from the base. Let's look at the second one. The positive ion is potassium. If it is coming from the base, it should be potassium hydroxide. Right here, it is from potassium hydroxide. The negative ion is sulfate. If it is from the acid, then the acid must be sulfuric acid, which is right here. Make sense to you? What I just did is that given a salt, given a specific salt, you can predict from what acid and what base that salt can be prepared through a neutralization reaction. Anytime when an acid reacts with a hydroxide base, a salt will be produced. Of course, it will produce water as well, but salt will be a product from the reaction of acid and a hydroxide base. I tell my students, consider salt as a child from two parents, one acid, one base. Sometimes when you look at a child, do you have a feeling that, oh, I can see how the parents of this child look like? Do you ever have that feeling? Sometimes you have that feeling when you look at the parents, you say, oh yeah, I was right. Their parents look like this. Sometimes you say, oh yeah, I made a mistake. They don't look like what I thought they would. Well, the difference between a true human child and a salt child in the neutralization reaction is that the salt child, from the salt, you can definitely figure out how its parents look like. There's no mistake. The parents will look like that. Because why? Because this child salt inherited a little bit from each parent. The negative ion, the salt is inherited. The heritage inherited the negative ion from the acid, inherited the positive ion from the base. As a result, to figure out the base, you take the positive ion, sodium chloride, keep adding hydroxide to it. When it is neutral, that will be the base parent. NaOH. You take the negative ion, Cl negative, you keep adding proton to it until it is neutral, HCl, that is the acid. Make sense to you? Well, if not, don't worry, let's move on. All right, so let's practice how do we predict from what acid and base a salt can be prepared. All right, remember, we are already concluded that the negative ion in the salt is from the acid. The positive ion in the salt is from the base. So here is the procedure you will follow to get the acid and the base parents for a salt. To get the acid parent, you keep adding protons to the negative ion. We already know that the negative ion is from the acid. So if the negative ion, for example here, if it is from the acid, how do you get that acid? You keep adding protons to it. Remember, that is the acid. All you need to do is to keep adding acid. You keep adding protons, You keep adding protons to it until it is neutral. For example, you have chloride, you keep adding protons to it until it is neutral, you're going to get HCl. Exactly, that's the acid. To get the base, remember the positive ion is from the base. So let's put in this case, let's put a positive ion here, Na plus. The procedure tells you to keep adding hydroxide ions to it until it is neutral. Why you do that? Because you know the positive ion is from the base, and the base was a hydroxide base. That's why you are going to keep adding hydroxide to it until it is neutral. You're going to get NaOH. Na is 1 plus, hydroxide 1 negative, 1-to-1 ratio, you're done. That is exactly the base parent. Make sense here? Let's use these two steps to do the second one. Let's see if we are going to get this. Let's do this together. So we will take the negative ion from potassium sulfate. The negative ion is sulfate. It carries a 2 negative charge. How do you know that? Number one, you should have memorized it. Number two, if you don't memorize it, the formula here, K2SO4, tells you it's 2 negative because you know potassium is in column number 1, which means potassium is 1 plus, and you have 2 potassium ions here. Therefore, sulfate must be 2 negative. Okay, to get the acid parents, you take the negative ion, keep adding protons to it until it is neutral. That is H2SO4. Good, very good. To get the base parent, you take the positive ion, in this case is K plus. I would like to remind everyone, potassium sulfate, the positive ion is potassium ion. It is not K2 2 plus. No. The subscript 2 here tells you you have 2 potassium ions. Each one is a K plus. So the positive ion is K plus. All right. So let's move on. You take the positive ion, you keep adding hydroxide to it until it is neutral. Hydroxide 1 negative, potassium 1 plus, so KOH. That's the base parent. Acid parent right here, we are correct. Base parent right there, we are correct. All right. Example. From what acid base can sodium chloride be prepared? We just did it. So we just did it here, okay? So let's do the other two. Looks like there are other two salts for us to try. Okay, what about calcium phosphate? We follow these two steps. Let's get the acid parent first. You're going to take the negative ion, phosphate 3-. How do you know that? Well, again, you should have memorized all the charges on the polyatomic ions. If you don't, given this formula, you should still be able to figure out the charge of phosphate is 3-, because calcium is 2+. Calcium is in column number 2. So calcium is 2+. You have 3 calcium ions altogether, plus 2 times 3 give you +6. So you have 6 positive charges in the formula. You have 2 phosphate ions. Each one has to be 3-. Make sense to you? All right, you take the negative ion, phosphate 3-. You keep adding protons to it to get the acid parent. That will be H3PO4. You need 3 protons to balance out the 3 negative charge. Okay, to get the base, you take the positive ion. Again, the positive ion is calcium 2+. It's not the subscript 3 here. That 3 tells you have 3 calcium ions. So the positive ion is calcium ion. You're going to keep adding hydroxide to it until it is neutral. It's going to be CaOH2. Make sense? All right, let's do the second one together. NH4Br, ammonium bromide. Take the negative ion, bromide, keep adding protons to it until it is neutral. That will be HBr, that's the acid. The base, take the positive ion, keep adding hydroxide to it till it is neutral. That will be ammonium hydroxide. Well, there's something extra we want to say about this compound, ammonium hydroxide. If you claim the base parent is ammonium hydroxide, there's nothing wrong. That's absolutely correct. However, normally, the most common base is not ammonium hydroxide. The common base for this one is actually ammonia. When you dissolve, all these acid-base reactions are in water. So when you dissolve ammonia in water, 1 proton will be transferred from water to ammonia. So ammonia will become NH4+. A proton transfer, it gets 1 more hydrogen and 1 more plus charge. Water, after donating a proton, it is going to become a hydroxide. That is ammonium hydroxide. That's what it is. Do you guys see that? So, some people will claim to prepare this salt, we will need that acid and ammonia base. If you dissolve ammonia in water, you will be able to react it with HBr. Does that make sense to you? And they will give you ammonium bromide. I hope I made that clear to you. Here on this slide, this is the last slide of this episode. I have a practice question here for you to figure out what are the acid base that can be used to produce each of the following salts from a neutralization reaction. So different ways to ask the same question. Find out the acid and base needed to produce this salt in the neutralization reaction. You can pause the video, try to figure it out again, start from a negative ion, keep adding protons to it until you get neutral substance. That will be the acid. Take the positive ion, keep adding hydroxide to it. You're going to get the base, the hydroxide base required. So do it, slow down. Once you're done, unpause the video, check the answer key.